Our next speaker, Mahooana Mlahleki, is passionate about growing his knowledge and skills in the electrical and mechanical engineering, programming, big data analytics, machine learning, and the Internet of Things. In a nutshell, he's a mechatronic engineer. Are you excited to hear more? Well, let's welcome Mahooana.
Hello, everyone. My name is Mahooana Mlahleki. I'm a mechatronics engineer. A very, very complicated industry. You go around and people say, what do you do? I'm a mechatronics engineer. What is that? That's the first thing you actually have to explain. But it's really an interesting career. Mechatronics engineering, it's actually a symbiotic combination of precision mechanical engineering, electronics, and computer design systems used to control and automate mechanical products with electrical signals. But therefore, this is just a definition, a literature definition, whereby if I am asked, I wouldn't really say it's the same kind of a definition. I would rather explain it and say mechatronics engineering is a plethora of interests in electrical control and instrumentation, which is EC&I. It's Internet of Things, big data analytics, machine learning, connecting physical and digital system, which ultimately create the smart factories. We have like RCL Foods, they're producing flour there, Coke, but the whole process and everything needs to actually talk together and machines need to communicate. Mechatronics, what career roles do you have when you actually venture into mechatronics? So it's actually an interesting topic because you are in a multidisciplinary field, therefore you can spread out anywhere you want. I'm also specializing in something at the moment, but maybe in the future I'll change. But you can be an electrical control systems and instrumentation engineer. You might as well be in control systems, just programming PLCs. These are industrial PCs or computers. They call them programmable logic controllers. So they kind of like give signals in and out. It's programming in the background. But you also troubleshoot and do SCADA systems as a control systems engineer. You're also moving into PLC programming, so you're only touching on one base, not developing SCADA systems and other, but you are also into software engineering as well as robotics. There are pick and places. You can see Mercedes-Benz, they have, while they're building their cars and assemblies over there, they have some nice robots that are putting everything together. They are also welding, so it's a nice, but you as a mechatronics engineer, you like the umbrella, so you can decide that, you know what, I want to go ahead here and work in this field at the moment. Also, automation engineering. We just had a data analyst, now scientist, so it's also part of the programming, and you can also venture into that. It allows you to actually blend in. But therefore, I said it's actually broad. At the end of the day, you need to specialize in something. I am an electrical control systems and instrumentation design engineer with PCS Global at the moment. So my role is quite interesting. I don't want to miss it for the world. Sitting down with a client gives me that adrenaline rush when at the end of the day I deliver his plantation to him or his plant and say, this is your machinery or this is your factory, but he only came with me with words and he said, listen here, I want to pack these bags. I want 20 bags at this rate and all that, so I have to actually think of a machine and visualize and design all that and also bring it to life, but it also involves procurement. So I'm going to talk a little bit of some of the things that I do during the day. So we have PNIDs, which are process and instrumentation diagrams. Mainly, this is for a water treatment plant. So this actually is a little bit messy because there are instruments in PNIDs which show allocation of instruments as well as devices and where everything is mounted. Therefore, for me to actually be able to design a plant, let's say a water treatment plant. I have to look at the PNID, identify the equipment that is there, but remember there also needs to be a programming involved there. Therefore, I need to identify what type of instruments are those. Are they digital inputs, digital outputs, analogs? You're sending values, maybe you're measuring level of a tank. So I go through that whole process just to actually get what you call an IO list. IO list builds up to all the equipment that is there, and I categorize it in terms of digitals, analogs, as well as in terms of inputs and outputs. It comes to the fascinating part. Programmers only come there and plug once I've designed and built that and someone in the factory has built. So PLC programmers, control systems engineers, they just come in and plug there and program. So you're gonna see that, oh, now the tank level, there's no water in there. It actually starts pumping from the borehole and filling in. But then again, for me, I have to actually spec the equipment, make sure that it's also safe and also up to standard. Therefore, I design control panels currently in my role, ranging from PLC control panels. There are also MCCs, which we call motor control centers for big, as well as substations, switch gears for big power transplants. Basically, one of the softwares I use is actually ePlan. I also use SolidWorks. So on the other side, I have a bit of a SolidWorks there. You can see some pumps and other stuff. So I can see it from a specification of a client and PNIDs, then develop that mechanically to show where that is, because with mechatronics, it's a little bit of a broad career. So I have a bit of everything, combination of electrical, mechanical, as well as programming. So I also need to understand the philosophy behind while trying to build all this equipment and machinery. So also have to build MCCs over there, which is quite interesting as well. I would like to say mechatronics engineering is actually, it's actually, you don't want to miss it. You want to be there, so I would advise students to start taking it. I would say for me, from graduation, I've never been unemployed. I've always had a job, moved from one to another, but it's because we are in demand. We are in demand. So in the future, you need to be there. IoTs, people need to analyze data from their systems. So you also have that capability to blend out. But if I need to change now from design, I will do so without any problem because I'm a mechatronics engineer. So I'll just move on to another field and program PLCs or become a data analyst or a robotics engineer. But it's really what we are really looking for into the future. And I've recently learned yesterday that I actually have a career in cyber securities. Just a workshop I was attending, but it was really interesting. So it's also part of mechatronics engineering. Thank you very much.